Okay, so the models we're going to work with for this worksheet are just the basic economic models. These are questions that you would typically see in an economics version of calculus, an applied calc or business calc or something like that. And they're really cool questions, and people taking normal calc should get to see them. So you're going to get to see them. So let's dive right in. So first of all, there's some basic economic theory, and these ideas are pretty basic. A profit in a certain amount, in a certain situation, is your revenue minus your costs. Okay, so the profit is the money you make is equal to money in minus money out, if you want to think of it that way. So the money that you have to pay to run your business subtracts from your revenue and gives you your profit. Now, in some exercises, you're asked to maximize revenue, and some you're asked to maximize costs. And so maximize profit. So you've got to read it really carefully, because sometimes you have already sunk the cost, and now, given your situation, you're trying to maximize the revenue. Or sometimes you get to adjust things. Another thing is X is the number of units sold in these questions, and P, little p, is the price at which each unit sells. Okay, so this should probably be return. So usually what you get is revenue of X is equal to P times X. There's other types of formulas you can run into, but these are the most basic formulas for this level of exercise. I'm not talking about upper level economics. This is just very basic, introductory, very basic things. And sometimes they use the little Q for quantity sold instead of X. Okay, another thing you need to know is the costs at 0 is equal to the fixed costs. So what you're going to assume is that you have some kind of cost function that does something. I don't know what. But this bit right here is representing your fixed costs, or the costs at when you have no items, your startup costs, your fixed costs. So those things, you have to recoup your fixed costs before you can kind of dig out of a hole. So you really hope that the money you're bringing in is going to dig you out of that hole. Okay, so the way this theory basically works is you end up with a revenue function, right? So your revenue function has to be, well, for this model, it's just a straight line starting from the origin and going up. So your revenue function is usually modeled by a line, okay? Because we're just assuming that each unit you sell is at a fixed price. Now, the models can become more complicated, but this is just the most basic model. And then the cost function, as you know, is usually modeled, it really should be like this kind of shape. But often we model it this way because it just makes the math easier. Now, first of all, notice that if you have a cost function like this, it's actually really stupid, because it's saying that the cost for additional items is going to be higher than the cost for your initial items. And the way this might work, for example, if you hire some workers and they have a certain fixed cost per hour, let's say this is an hourly cost. Actually, you might see a cost function more like this, that maybe it gets steeper when you have to start paying them overtime. So that would be a situation where you actually would get a steepening of the curve, but that's only if you have a fixed number of laborers. Normally you would just hire more laborers, and that would happen something like this, okay? So keep those in mind. So usually in these basic economics courses, we'll say, like, maybe here's your cost function, here's your revenue function, and then when you do profit, and actually I've been told in economics they sometimes use the letter pi to keep from confusing you from little p, which is price. So you can use capital P or capital pi. Profit is revenue minus cost. So what happens is you end up with this kind of like negative shape thing going on. You're going to have wherever your first break-even point is going to be here. Here's your maximum profit, and here you've cranked up. Well, maybe. Well, it's really there's a whole bunch of complex things. Your cost function doesn't really look like this, but in the simplified model, then you end up making no profit if you make too many items because the cost goes up. That's not the real mechanism, but for this simplified model, that's what happens. Okay, I'm going to come up with this just random question I made up, and the numbers are probably ridiculous. So usually if I'm going to give, let's say, an exam question, I would just actually make sure the numbers come out nicely, but I'm going to just sort of wing it to show you the structure of what's going on. So a typical question on a worksheet or an exam or something like that would be, you have a cost function and a revenue function, and you might be asked to, maximize profit, please. Okay, and so profit, you can use P or pi, is revenue minus cost. So it's going to be, here's my revenue, and then take away the cost and take away 10 x's. So I'm just going to make this 190. Okay. Now you should know that the next thing I'm going to do is take the derivative. Actually, I usually tell people to shortcut because the vertex is always at minus b over 2a. And I've been telling people that since time immemorial, and they still want to take the derivative. So let's go ahead and take the derivative. So we often say MP, meaning P prime, okay? Marginal profit is marginal revenue minus marginal cost. Well, marginal revenue is just R prime, and marginal cost is C prime. So those are all different ways of saying the same thing. So you're going to just go ahead and take the derivative, set it equal to 0, solve for x. So x is equal to 190, so x is equal to half of that. Is that right? No. I can't divide by 2. Hold on. Okay, so that would be the number of units sold at max profit. Okay, and since this is an economics exercise and it's a downward facing parabola, you don't actually have to go through the second derivative test or the first derivative test to prove that that's a max, because you just already know it's one of these guys. There's the max. So when these kind of questions come up, even in an exam setting, I don't usually dock points for people not doing the second derivative test or the first derivative test to prove that's a max, because it's clear. But in a normal question, when you locate a critical point, you have to go through a lot more steps to prove that what you found is indeed where the max occurs. So if you want to maximize the profit, we're going to go ahead and find out what this is, and I'm going to just do that on a calculator or Google or something, and I'll come back to you with that. Okay, well, my biggest fear didn't happen. I was afraid that my maximum profit would be a negative value, but it's not, so we're happy. And we can even reverse engineer what is like the price per item at that level. And so then you could do something like this. You could say, here's the total, you could find the total revenue. So you know the total revenue, and so if you calculate it, minus 95 squared, and then you divide by the number of items, oh boy, that x looks like an x. This should be a times, and the number of items is 95, is going to be price per item. I guess I'll go calculate that. And it looks like it's $105 per item, which is not bad for a question I just made up on the fly. So let me just make sure I got all the important ideas for you here. So that's all you need to know for the middle part of the worksheet, but there's still, the first part of the worksheet is graphical and the last part is tabular. And there is one more concept I wanted to share with you, which is not on the worksheet, but it's part of this model. So let me just do that first. There's this idea that when when you're looking at your profit function, it looks kind of like that. Where the profit is maximized, notice that P prime equals 0, but profit rather is revenue minus cost. So the marginal profit is the marginal revenue minus the marginal cost. So when this guy equals 0 is when this guy equals 0. So marginal revenue equals marginal cost. This is when you maximize your profit. So it's just pushing symbols around basically, and it's not really that complicated, but it's something that's kind of cool, and I just wanted to show it to you. Okay, so you have some sort of question on your worksheet where you've got a cost function and a revenue function, and you're supposed to graph the profit function. You don't really have to, because I'm not going to test you on what your graph looks like. I'm going to ask you what the profit is at certain points and what the cost is at certain points. So there's like a grid you need to fill in. So the way I've set it up, if you look at the revenue function, it crosses, this isn't a perfect picture, but it basically every third, as x goes every 3, you're landing on another integer. And so I'm asking you to estimate pretty closely what's going on. So in this case, if you say, okay, what's the revenue for 0, 3, 6, 9, 12? In this case, it would be 2, 4, 6, whatever, okay? But then you want to go over here and also make an estimate. In this case, cost is at 0, it's 2. And then at 3, it's going to be like 2.5. And at 6, it's 5. And at 9, whatever it is. Okay, so 10. So what you're going to do is you're going to just say, well, profit at 0 is -2. And okay, so profit at 6 is revenue minus cost. So it's 4 minus 5. This doesn't look very promising because actually the costs are going up faster than the revenue. So I built this problem like very poorly. Okay, so profit at 6 is going to be 4 minus 5, which is -1. So we already hit our maximum profit and we are in bad shape. This is just not a good business model. But it tells you how to do the exercise. So this is going to be revenue, which is 6 minus 10, which is -4. So sorry guys, you're not making any money on this product. Very bad product, very bad investment. But that's the process you want to go through. And so that's enough of that. Okay, so you have a grid in your homework that lists something like this. You've got quantity, revenue based on that quantity, and cost based on that quantity. And you're going to look at this combination of revenue minus cost. So profit, in this case, would be 75. So you're going to look at each of these sets of cells and figure out what the profit is at each quantity. Now, I'm not asking you to do any kind of guessing about what happens in between. You're just going to look for where the profit is maximized, and you're just going to say whatever the quantity is that goes with that, you're going to claim that that's a close estimate of the quantity which maximizes that profit. And then what you're going to do is that you're going to ask for the price of what that object is, or whatever you're selling. So let's say, for example, this is maybe you sold 20 of them. If you sold 20, then what is the price per item is the revenue minus the quantity. So in this case it would be 100 divided by 20, or it would be 5. Okay, whatever the monetary units are, yen, lira, dollars, euros, I don't know, whatever it is. So that's how you do that. And again, if you want to know what the fixed costs are, It's whatever's in this box. It's however much you have to pay right off the bat before you even produce anything. So that would be your fixed costs. Okay, so that should be all you need to know for that worksheet, and I'll see you in class.